Good afternoon.
Good afternoon. Hi, everybody. Good afternoon. Thank you for being here. Welcome to pre-calculus today. We're just getting myself set up here. But welcome, y'all. Let me go ahead and take us to our check-in question so we can see who we have here. Correct my and update my attendance. So, hey, if you haven't already, if you want to go to Google Classroom, make a copy of today's slides. But keep in mind though, today we're going to be mostly on Desmos after we go over the recap. So, I mean, up to you if you want to open today's slides to follow along. But yeah, welcome everyone. Welcome to April 21st. So, I have a question for you. Would you rather have a pet dinosaur or a pet dragon? Go ahead and think about this and enter in your answer. Maybe you want to tell us why one is better than the other. And I'll check attendance, y'all. Welcome, welcome. If you're just coming in, we are on the check-in question. Okay, I see some stuff there happening in the chat. Let's see what is it? What do we got? Okay, overwhelming. overwhelming. Wait, overwhelmingly everyone's saying pet dragon. They said dragon, they're just dinosaurs but better. We got dragons. Okay, we got one dinosaur. Dinosaur because I hate heights and dragons fly. And we got dragon to fly. Overwhelmingly dragons. Both would eat me if I made them mad, but I choose dragon. Yep. Okay. So it looks like I mean most of us are saying dragons. We got one that says dinosaur. When I first asked this question, I think my younger sibling chose dinosaur too, and I chose dragon. But specifically because aren't dragons are like mythical creatures, right? So they have special things, like some can breathe fire, they could fly. Yeah, so I would also choose a dragon too, but hey, if you chose dinosaur, that's cool. I asked my sister, like, how come dinosaur? They're like, oh, it's I don't know. I forgot what she said. But yeah. All right, and we say I would say dragon because they fly, but I'm also afraid of heights. So I don't know what I would do either. I would want both to be honest. We got yes, magic. Yes for the magic, y'all. Okay, awesome. Let me go ahead and see who we have, who we're missing. Again, a majority of us are saying we'd like a dragon as a pet instead of a dinosaur. Okay, so now you probably want to correct me if I'm wrong on the attendance. And I am basing this off the check-in question. So if you didn't answer the check-in question, if you could do that, please. So this is who I'm missing. I am missing Jalen, Tori, Denise, Brandon, Gerardo, Miles, Jirel. Let me know if you're actually here, please. So I'm going to repeat the names. Kyla is also missing. Leon, Sincere, Celia. So that's who I met. Oh, welcome, welcome. I apologize, Tori. You're here. Let me fix that up. Okay. And then someone just popped in right now. If you could answer the check-in question, that would be lovely. So this is who we're missing one more time. I am missing now Jalen. I am missing Denise, Brandon, Gerardo, Miles, Jirel, Kyla, Leon, and Sincere and Celia. So let me know if there was any accidental mistakes in that second run. It looks like we just got Miles. Oh, and we got Gerardo. Thank you so much. All right, y'all. Thank you for sharing. We got another dinosaur though, but it looks like the majority of the classes saying they'd like a dragon instead. So awesome, y'all. Thank you so much for sharing. Let's go ahead and take a look at what we're doing today. Okay, so here's our agenda, y'all. I just took attendance. We're going to recap and we're going to take a look back into that Google form that we started on yesterday. I think I'm still missing some of you to submit that form. Please do so I could get more data on where everyone is at. I definitely want to see where your understanding is at and how I could adjust my instruction to better address what you all need. We got a whole class Desmos coming up, so yay, more credit opportunities. And I said this yesterday, but I'm gonna say it again. Anything we do in class is worth the same amount as an asynchronous assignment. So please do your in-class stuff. It is worth a lot. Yes, and then we'll have a checkout. Our next asynchronous assignment that's coming up for us is due tomorrow, everyone. So it's due tomorrow, midnight. So there's some time for you to get started today if you like, or you could start it tomorrow. So you have ample time to get started on async number 10. Woohoo, let me know if there's any questions about anything I just said. Let me know. All right, y'all, let's jump into that recap. So yesterday we talked about how a circle, something like a Ferris wheel, is able to create something like a wave. And how we're able to do that is you imagine you're a rider on a Ferris wheel and basically you're measuring your height from the ground to the top and so forth. And you keep going around and around. And each time you reach to the top, you reach a peak, you go back down. After 3 minutes, we complete one cycle, one revolution. You go back up on the Ferris wheel at the very, very top, go back down, and so forth. So we notice how if we map the height of a rider on a Ferris wheel, we get a wave. So that was like a huge big idea here to make connections. And we also talked about how to find the period of any wave. So we're trying to kind of extend our knowledge away from the Ferris wheel more into application. So if I just gave you a general wave, would you be able to tell me the period? Is basically the goal. We're going to also continue on this goal because I definitely want to talk about a Google form that y'all did yesterday. Okay, actually, if there's any questions on recap, let me know. If not, I want to talk about yesterday's Google form. Again, if you did not get to turn it in, please do. But if you do it, if you could send me an email so I could get notified and check it for you, that would be awesome. Question number 3 on the Google form asked you if this funky looking function was periodic or not. I put why or why not. You could take a look at the various different responses you all put in. So a lot of you had said that yes, it is periodic. We do have some no's. There were some no's, more than just I have captured here. So the function is not periodic because it never touches the x-axis. Don't know if I said that right, but I know for it to be periodic, it needs to go above the line at the very least. But then we have the function would be periodic because the peak of each waves to 2 pi at a certain point, even to where the length of one of the intervals and how the waves keep repeating makes the function periodic. It says same motion. I see constantly repeated. I see same shape is being repeated. Yeah, so actually, I definitely want to bring this back because actually, yes, this is an example of a periodic function. Um, and it actually doesn't matter if it's shifted here like it is. You know how it's below the x-axis, which was great that the student kind of brought that up. It actually wouldn't matter. So if it's shifted down, shifted up, shifted all the way to the side, whatever you'd like to think of it, it wouldn't matter as long as there is a repeating shape as you see here. Same shape is repeating. Same points are repeating. How specifically you would say something's periodic? Let me bring you up this slide that I showed yesterday. So this was actually in our slides from yesterday. It was actually yesterday's slide 9. So this is the exact definition of what makes something periodic. So see, I saw the word repetition coming up, so that's awesome. So periodic functions are functions that create a repetition of values at regular intervals. So regular intervals means after a certain period of time, the function will repeat or its outputs will repeat. And basically a period is the length of one of those intervals. So definitely want to talk about that because I wanted to make sure there wasn't any misconceptions, sorry, about this here problem. It looks oddly shaped and so forth, but it is also periodic as well. So yes, let me know if there's any questions about that, of what I just said. Getting more folks coming in, yay. Welcome, welcome. So I see you, Jirel. Someone else just came in. If you could let me know via chat, that would be awesome. Was it Brandon? Let me know if that was you. And we got Jalen coming in. Yes. Yeah, I see you. All right. Okay, awesome. So I've updated attendance. Thank you all for coming. Happy y'all are here. I am just going back and talking about yesterday's Google form. And now I'm going to transition us to this one. So take a look at this, y'all. This question number 4 on the Google form had the most variety of responses. So I'll show you the picture right now, but I want to just show you what are the varieties. Some said, I think the period is 2.25 pi, but I don't know, explain why. We have some steps and processes, but then still being a bit confused. We have more confusion coming up. Then we have an answer here is 3 pi, and we could take a look because when I look at 0, we can see the unit goes from negative to positive. Usually is the opposite, dips and goes back and tries to dip again at 3. That's when I know that all has been done before. It's trying to repeat, so 3 pi represents the distance. So if you understood that, awesome, very elaborate. Another person got 3 pi, so let's take a look. So the following period I got was 3 pi, and the strategy I did was the maximum method. And it helped me to figure out what the exact distance I have. We got NA and we got stuck. So this tells me, right? This is giving me feedback. Oh, wait, what's in the chat? Oh, okay, no problem. Oops, was that you, Danny? Was that your answer? Oops, sorry about that. Let me go back to.
Yeah, the really long one.
Oh, okay. So let's try to decipher this. Let's just try and see. So what I could see, right? And this is what I mentioned when I say the Google form was for me to also see where you're at. It's also for you to see where you're at. For those who put, I don't know, I'm not sure, that's a great assessment of your own understanding. And it also lets me know that we need to cover this again. So we need to talk about how to find the period of a function. Some of you did get an answer of 3 pi. Let me explain out. So the answer is, it is 3 pi. The answer is 3 pi, and I'm going to go ahead and recover how I explained it, but there's also these explanations here if you want to check them out. You can check out Danny's response because I think he does it a different way. I'm going to show you the way I showed everyone in class, but if Danny's makes sense, you could go with what he said. So this was the wave that I initially gave you all, and I asked you to find the period of this. And so notice on the x-axis, after like about 4 boxes, 1, 2, 3, 4, you get pi. You have another 1, 2, 3, 4, it's 2 pi, and then so forth. This is 3 pi. So 2 answers were saying the answer was 3 pi. Let's investigate that. And I'm going to be using the strategy that was mentioned down here. It says I did the maxima method is what was mentioned. And that's the method I showed yesterday. So let me stop my screen share. Perhaps I need some support. So when I'm trying to get used to the technology in the classroom, when I stopped my screen share, do you all see a graph paper with the same, you know what I'm saying, the same wave on a piece of paper? Do y'all see that as your main screen or no?
What do you mean by
Do you
that?
see user's iPad 3 as your main screen?
I see you.
You see me, okay?
You can just pin that video.
Let me do this now. Do you see it now?
Yeah.
Yes.
Okay, I think I had to spotlight that. Okay, so right now what's spotlighted is my piece of paper that I printed. So I'm gonna, since my speaker's on my computer, I'm gonna just pick up my computer and just move myself closer to this area on the desk. Okay, so that way y'all can hear me. And this is my piece of paper that I'm gonna be working on. Oh, okay, I see some private messages. And yes, if your internet is wacky, yes, you could re-sign in. Let me turn off my camera. Okay, there we go. Okay, y'all. So I'm gonna try to project my voice, and I just printed out a large copy of this problem from yesterday. So the maxima method that a student mentioned on the Google form, this is the method. You identify, sorry, someone's coming in. You identify 2 maximums on your graph. So step 1 is to identify 2 maximums. We call them, the formal way to say maximums is maxima. Like that, maxima. Man, it's kind of blurry. But anyhow, this would also work if you did it with 2 minimums. But let's just focus on the maximums. So this is how I would do it using my fingers, everyone. So I would just measure the distance between these 2 maximums. So I'm just right now measuring with my fingers. Then I go down to the x-axis, starting from 0. My thumb is going to be on 0. And I'm going to end up where the second finger's at. I look, and it is exactly at 3 pi. So that is one way. I don't know what you want to call that. That's using the fingers to measure your period. Sorry, let me let someone else in. Okay, next. The other method. The other method was that I showed you all was like kind of drawing a line between the 2 maximums. And then what I did is I took the line and I shifted it down, and I used the x-axis as a ruler. And then Danny put something there in the chat if y'all want to see. I can't fully see it at the moment, but I'm going to do a strategy that another student mentioned that I did not get to screenshot, but I'm going to do it. So they said they counted these boxes. See these little square boxes? They counted how many boxes were between each maximums. And then what they did is they counted the same boxes starting from 0 and then saw where it landed up at. So let's count the boxes. So this is, I'm going to start at 1 maximum. I'm trying to make sure my hand's not in the way. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I counted 12 boxes. The problem is we don't know what 12 boxes represents as a length. So that's why you go down to the x-axis and you count those very same 12 boxes to figure out what that is. So I'm going to go down and I'm going to count 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So lo and behold, this method also is going to give you a period length of 3 pi. So I'm hoping that was helpful. Let me know if there's any questions. And I'm gonna check out what you put in there, Danny, so I could and then, oh great, why do I always start at 0 was a question that was just asked. Because you wanna look at your x-axis like a ruler. And when you measure things, you start at 0. That is a good question. Any other questions coming up from what I just did on this piece of paper? Cool, because questions, they are gold. So I hope I addressed that question as to why we start at 0, because when you're using a ruler, you start at 0 too. It makes it easier to see what your measurement is. And I'm treating the x-axis as a ruler, and it told me that that length was 3 pi. So cool. I'm hoping that was helpful, but if questions are coming up, let me know and I could go back to this. Oh, great. So I have another question. So it's 3 pi. That's correct. The answer to this problem, the period, is 3 pi. I'm writing this large so you could see it. So period length 3 pi. That means this here wave repeats every 3 pi. So each time you go a length of 3 pi, the same wave is going to repeat. That's what the period here means. Yeah, let's see. Are there any other questions that are coming up for us? Oh, okay. And then Danny just put find it so easy to start at 0. Awesome. So I think what Danny did, I think you saw it. I'm not sure. Correct me if I'm wrong, but you saw it dip down, dip up, and come back, and that's how you knew it was 3 pi. Not sure if that's what you meant in your response, but if it works for you, yeah. So if you see you identify that this is like 1. And so from this 1, you kind of like knowing that, so Danny says it goes down and then back up, knowing that that down and back up represents 1, you could also use that strategy too, whatever works. But this is I'll just call it the maximum method, the same method that that student mentioned. Okay, everyone, I'm gonna grab my laptop and I'm gonna go back and share my screen. Let's do this. Okay, I am back. So again, thank you again for doing the Google form. If you haven't yet, please do it. It's going to give me some information to see what we need to kind of focus and talk about more. Let's go on to what we're doing today. And again, if anything else is coming up about this problem, let me know. I still got my paper out there and I think it's still spotlighted. So let's do some stuff today, everyone. We're going to get some credit. Yeah, okay. So someone said, I forgot to do the Google form. I'm going to do it later. As long as you get it in, that is great. It makes me happy. I don't like, even if it's late, as long as you're getting your learning in, I am happy. Okay, everyone, let's go ahead and go to student.desmos.com. Go ahead and type in this code. Let's have about a minute to get all in there. And then I'm gonna join you as well. I'll put the directions back in the chat. I'll be right here.
So do we start?
Hey Danny, sorry, I was updating attendance. We are gonna go ahead and get started, and my timer just went off. I was giving everyone a minute to go ahead and get logged in. It looks like you're already on there, so awesome. Appreciate you. Let me go ahead and join you. So, actually, no, you don't start. I'll be pacing y'all, but I mean, if you already got a chance to look ahead, that's awesome. So for example, I only see 12 students. We need to get more students in here, y'all. So I see Gerardo, I see CJ, I see Yaisa, I see Danny, Brandon, Rebecca, Zion, Jasmine, I see Tori, I see Brenda, I see Rosario, AJ, Miles, Alexander. So far we got 14. So we're still missing a few folks. So let's get ourselves a little bit of time. And I'm gonna turn on my pacing. Some of you are probably eager to get a start on this, but I definitely want to explain this. So I'm gonna restrict the screen. So I got everyone to the first bullet. Okay, awesome. So let's see who we're missing here. It's gonna be individual, Danny. So individual. We're all doing this together, actually. So we're all going to be getting individual credit. Great question. So individual. All right, so let's see who we're missing. I feel like we're missing a good handful. So if your name's not on here, I'll just send you a little message to see if everything's okay. I know. Oh yeah, no problem. Just go ahead and jump on in. I'm trying to see who we're missing here. Okay, we got 15 students in. Hmm. So these are the names I see right here. So if your name is on my screen, you're good. You're ready to get started. So awesome. Props, 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 props. Awesome. I see Sam. I see Ruben. Oh, we have where's the code? Let me go ahead and grab that. Sorry if y'all were trying to join via code. Let me type that into it's gonna go right into the chat, everyone. Click on the link and it's gonna take you directly here. Yay, we got 16 students in. I think a few more needed that link. Still feel like I am missing. Oh, I think I know. Let me go ahead and send a direct message. Okay, cool. So if I didn't see your name here, I went ahead and sent you a private message. So I hope you can join us. I'm gonna go ahead and get us started, everyone. So on the first slide, it says, this Desmos will help you start asynchronous number 10. Asynchronous number 10, everyone, that's the thing that's due tomorrow midnight. We're actually going to get a start on it together. What I mean by that is we're just going to put ideas out there. We're going to put some ideas out there. That's going to give you some idea on how to actually do your asynchronous number 10. So the expectation is you're still going to turn in asynchronous number 10, but we're getting our thoughts out about it here together as a class. So it's going to be a great way to support those of you that perhaps got scared if you opened up asynchronous number 10. So let me know if there's questions about that. If not, we'll jump into it. Cool. I'm gonna go ahead and move us to slide 2, everyone. So slide 2. So on asynchronous number 10, you're gonna see a picture of this windmill and it has like a point P that's labeled on one of its windmill, I guess. What would you call it? One of its blade, there we go. You see a point P labeled on one of its blade. I want you to think about what are some possible questions you think a teacher would ask you about this windmill, or even that I would ask you. So what questions do you think you could be asked about this windmill? It could be anything. Just think Think about what kind of questions you would be asked. You can even relate it to what we asked about the Ferris wheel and so forth. And yes, awesome. That is something that could be asked. I'll go to my teacher mode to see, oops, let me also anonymize this. There we go. I'll let you all type in what you think, what kind of questions you'd be asked. Again, there's no way you can get this wrong. This is all about just your ideas. Okay, I'm gonna go ahead and bring us back. Wow, to be honest, no, I wasn't talking. And then to be honest, like, wow, I actually am getting a little blown away by like the very like it's showing that y'all are like using the vocabulary and you're already kind of thinking about this without being prompted. And for me, that's amazing right now. It's really amazing. And some are even going outside of the box. So how long until you get a full cycle? That's a legit question. What's the first thing you should find to make an equation? Oh my gosh, that's true. That's a good one too. Like, what in the world? Um, is the windmill moving at some rates or is it still? Oh, that's a good one. Like, how long will it take to make a full turn? Sorry, y'all, I can't read everyone's juicy question, but all of these are fantastic. I'm just pointing out a few. I like, what is the height and how fast does it move? We're getting max height of the windmill. We got, what's the speed of the Ferris wheel? We could just replace Ferris wheel with windmill, totally. And I see height coming up, and I like this one. Is this a periodic function? That's a good one. Yes. I love like the vocabulary popping up. Okay, y'all. So on asynchronous number 10, you're going to see this picture of a windmill with a labeled point P on one of its blades. I'm going to take you to slide number 3. And what slide number 3 is, it's going to show you the context of the problem. So now let me move you. The context. If you look, it looks like this so far. You see P and you also see a screenshot of a graph. But if you scroll down, you get the context. It's all the way down here. If y'all can see my screen, if you scroll down, you got the context. So here's our context, everyone. It says the center of the windmill is 2 meters above the ground and it has 5 blades. Each blade basically is a meter in length. A point P is at the end of the blade that's pointing directly to the right of the center. So I guess that's how they describe where this is at. It's to the right of the center. That makes sense. Here's a graph showing the vertical distance of point P above the ground as the blades rotate counterclockwise. So someone asked a good question earlier, like, is this moving or is it still? So according to the context, it's telling us this is moving in this direction, counterclockwise. So it is moving and it is not still. So I enjoyed that question. Next we have, P starts as shown in the picture at an angle of 0 radians relative to the center. So that is our context, everyone. And here is the windmill and here is the wave. We're gonna break up and try to figure out what questions we're gonna be asked about the context of this problem. And we're gonna try to figure this out together. And let's see what's in the chat. We said, does it take 2 pi? I don't know. Try and see if your method works, Danny. So you're asking if its period is 2 pi. Maybe that might be something that we're gonna come up and asking soon. All right, y'all. So that was the context. I'm gonna move us on to 4. Number 4, you will have to input something. So let me move everyone here to slide 4. There's somebody still on slide 2. Okay, everyone. So once you hit question 1, this is what the question is asking you on asynchronous number 10. Let me go to student mode. So this is what you see. I know it's kind of tiny, but what you can do, hopefully, is you could, zoom in if you'd like to see a bigger picture of your graph. But I'm curious to know what y'all think. What are the inputs and outputs for this particular problem of the windmill? What do they represent when you connect it to the motion of the windmill? Go ahead and try to answer this to the best of your ability, and we're going to take a look at what y'all think. So this is question 1 on asynchronous number 10, but we're just putting our ideas out there right here into the Desmos. Take about a minute on this part. I'm giving us a bit more time. I do see a few more of us are typing. So again, what are the inputs and outputs of this? It could be a little bit challenging if you try to take a look at this, right? So again, don't be afraid to be wrong. Let's just put our ideas out there. Let's figure this out together. Okay, everyone. I'm going to go ahead and bring us back. So I was definitely also taking my time and processing what y'all were thinking about this problem. I do see two being like I see a consistency of two coming up a lot, or like 2 pi. Someone said 2 pi is the time it takes for a period to complete. I'm curious to know about inputs and outputs. So here again, I see input is 2 and the output is 1 each way point. Has an x added, x-axis I've added 2 more than the previous y stays the same on 1. So I want to know like the input being 2. Curious about that one. For me, it's like it's a wonder. But I do see 2. Like if I look here, I mean, I see 2, but I see 2 in many places. I see 2 right here. I see it divided by 2. I see 2 right here. So many different locations. So let's see. Okay, so here we have the input is where P is at right now, and the output is where it'll end up for the first section or period. And then we have another one. The input could be where point P is located currently. So again, right now, and the possible output is when P reaches max height. We have we have the output perhaps being connected to height, like the Ferris wheel. So let's talk about this, y'all. So I do see a variety of answers, and I think I want to use Emmys. So I don't know who Emmy is in this room currently, but I want to use what they said. The input is the X value on the left side and the output is the Y value on the right side of the numbers. You would think, well, that's something we learned in algebra, but that thought right there, I think will help guide us actually. So I'm zooming in into our picture. So I like what Emmy said. So they're saying that this is your input. Like for example, X would be 0. Your output is a number that's on the right side. So if that's the case, when I'm asking, I think there was confusion in what I mean when I'm like, what is the input? So the input are basically, I'm asking, what does X represent in this problem? Let me write that down. Or what does X represent in this graph? This graph. That is the golden question. Well, let's look at the X-axis, everyone. What is the X-axis counting? We circle the whole X-axis. I know it's a little blurry, so I'll give you that, but what is this counting as our input? Yeah, so Danny, you said radians, and radians is a way to measure what? Radians measures what? And it is
The circle. Wait, a circle.
Yes, that's right. So that was that you, Zion, talking? I saw Zion pop.
Yes, it was.
Yes. And then yes, like the radians that are on the circle. And then I see Danny put in the chat angles. Yeah, when we learned about radians, we talked about radians being another way to measure angles. So that is correct. Our input, everyone, is radians, and they are measuring the angles. So they're measuring the angles that P is making around the windmill. So I'm going to write that down so that we're clear on what the input is. So X is our input. X, our input, is measuring angles in radians as P rotates along the windmill, around the windmill. That makes more sense. So that is actually what our input is. And it's through this discussion together that we're trying to like kind of break this up and decipher what we're looking at. It's through this discussion. And you notice how it's like I'm borrowing some of the stuff that y'all were saying and what you're currently saying. So we're building our knowledge together. Okay. So if that's our output, I did mention, I did see, and I don't want to zoom out again, but I did see. So when I'm asking what's my output, I'm asking about the Y values. And I noticed that my Y value here is 2, then it's 3, then it's 1, then it's 3, 1, 3. What are these representing? What is this y-axis measuring was the question. What are the outputs? Okay, so we have time. We have that the y-axis could represent time. Oh, or we got or height. Danny, you put maxima, but what would those maxima and minimas represent? Are you saying they represent time or height? I have another height here in my direct message. So it's either time or height. And then Danny said highly, oh, height. Okay, so it's height, we have a few that said time. What if, I don't know, what if we went back to the context of the problem and saw if it gave us information about whether or not this is time or height? But I do want to say something, y'all. If this is time, so let's just say this is 1 minute, 2 minute, 3 minute, 4 minute. Let's just imagine that scenario. That's saying that at 2 minutes, it's here. And then at 3 minutes, it's at this here, at this radian, and at 4 minutes. So I mean, I'm guessing that logically that could make sense. So I just wanted to first see if that made sense. Okay, let's go back to the context of the problem and see if they give us information on what the y-axis could be. So let me delete this. So again, input, radians, angles. That's what we're measuring. I gotta zoom back out and somehow I'm struggling now. Okay. So let me stop my pacing because I don't want to drag everyone with me. I'm going to go back to slide 3. And I'm going to go back down to the context. Center of the windmill is 2 meters above the ground. So what I'm seeing is a height measuring of the center of the windmill. And I see the 2 meters kind of right here. So it starts off, it says, it starts off at a height of 2 meters. So I see the 2 here. And blades. Okay, cool. And then we have other context. I'm just trying to see where else that happens. And we see that the blades are representing 1 meter in length. So according to the context, it's looking like, and let me draw on this. So they're saying that the center, from the ground to the center of the windmill, it is 2 meters. And that's actually precisely the height that point P starts at. So it starts off 2 meters above the ground, but then P is going to increase its height. And we know that the blade, these blades here have a measurement of, it says 1 meter. And it's going to go up. So it would make sense that P starts at a height of 2. And then when it's at the very top, it reaches a height of 3. Whoops, I'm kind of going over that. Height of 3. So then I would say that instead of height, according to the context of this, it looks like my P is representing height. So height of P to the ground, if we're measuring it from the ground. So this would be P at the maximum height, which would then be supposedly 3 meters. So that's me going back to the context. That gave me a little bit more information. And it's telling me that my Y, my output, is height, everyone. Let me know if anyone needs another explanation as to why our output in this case is height. So it's same like the Ferris wheel, everyone. So it's kind of like we're tracking the height over time. You could think of this as you on a Ferris wheel and you're going around and you're just measuring your height over time. So let's see if there's questions about that. And let me go ahead and take us back to this one. Well, if you do have questions, don't worry, you can hold on to it because we're gonna go into, I'm gonna turn on my pacing again, y'all.
Wait, hold up. I have a question.
Yeah, go ahead.
You have office hours tomorrow.
That is correct. I'm gonna have them tomorrow at 2.
Thank you.
Of course, of course. Yes, and then let me see, what time is it right now? Okay, we got about 5 minutes. So we gotta dig into this, y'all. So right now we actually did something very, very worthwhile. We have found out from this graph that the input is angles. I'm just repeating it. Angles measured in radians. We need to be clear, at least like when we're looking at this graph, what this is. And the output is height of point P from the ground. That's what we're actually looking at when we're looking at this here graph. And that's how we're getting these up and low values. because point P starts low, goes high, goes back down, and so forth. So that is what we're actually taking a look at. Oh yeah, no problem. Okay, so I'm gonna go ahead and clear my screen. What I want us to do now is to annotate. So that's our next slide, everyone. So I'm gonna take us to our next slide. And let me go to student mode. Okay, so I went ahead and I copied and pasted the context right here. So you have this to kind of look back into. And what I'd like you to do, and it's right here, the directions are here, but it's tiny on my window. So let me zoom. It says, I want you to annotate where the center of the windmill is at. So I did show you, but I want to see if you know it now. Draw where the 2 meters is at in the windmill. Circle where you see a height of 2 meters in the graph. So you're able to draw on this. And then annotate anything else you might find useful when you're making connections between the windmill picture and your graph. So that is what we're doing here. And it looks like this is going to be our last slide for today. So I'm trying to erase the arrow. Oh, wow. I was trying to erase it with my Zoom thing, but it was on Desmos. So you are able to draw on this, and this is what I'd like you to annotate, everyone. So that is the directions. I'll go ahead and pop in and see if we got that. So I'm gonna take that out. So let me go to student. Teacher mode. There we go. So I see Emmy, Richard, and Karen trying to start their annotations. I see Richard has drawn the center of where the windmill is, the height of the center of the to the center of the windmill, which is at 2 meters, and they circled where they see that on the graph. So this is what I mean about annotating. So follow the directions on what to annotate, y'all. So let me know if anyone has questions. Good, I see more of us starting on it. And then let me give you all a bit, and then I'll start to pop into some and see what patterns or anything interesting that comes up as we're doing this analysis. Oh my goodness, Joseph. I don't know who you are, Joseph, but Joseph drew like a line down through the middle, and oh my, you know why it's like making me like, oh, my breath. So, like, I don't know, but I don't know if I'm interpreting this wrong, but I wonder if they put this line here because these are all the different points that are representing a height of 2 meters. I don't know, but that's what I'm seeing when I see this line drawn through there. So that one's interesting. Cause if you think of it, y'all, when P is rotating, it's gonna reach 2 meters more than once, isn't it? It's gonna reach that same location more than once, that same height. And I'm not sure, Danny. I am not sure. Look at this, y'all. So I like this one. So this one is Cynthia. So they labeled where 2 meters is at, and they circled the first point, and they also circled this last point. So they know that P is at 2 meters here. It's also at 2 meters here because that is the Y. It is a height of 2. It's at the same location. But there's more, right? Isn't there more locations where it reaches that height of 2? So this is just, I love this because they have 2. Okay, we got our line people. And then we got kind of like this. So this, and all of these in between are representing a height of 2 meters. Oh, okay. I heard somebody log out. So it looks like it's time, everyone. So again, this asynchronous is going to be due Thursday midnight, but we'll go ahead and finish up Desmos tomorrow. And you all have a way to get started on this asynchronous without it being scary or confusing. You now got some ideas out there. Okay, everyone. Awesome. I'm gonna see you tomorrow. Bye, everyone. Have a great day. Bye. I got office hours tomorrow.
Bye.
Bye. Bye, y'all. Have a great day.